So, let's say we are asked to find the equation of a parabola, but we're not given a graph of the parabola, just information about it. What does Ms. Ball say if we don't have a picture? Draw a picture. Let's take apart this information and use it to create a graph so that we can find the equation from that graph. Okay, step one, easy. They told me that I have x-intercepts at -8 and 0. Okay, let's draw a picture of that. I have an x-intercept at -8, and I have an x-intercept at 0. Check. Okay, I'm told that the range of this parabola goes from -20 to positive infinity. When we think about parabolas, we're thinking about a shape that either has a bottom or a top. What is the point that restricts how far down we go or how far up we go? The vertex. Every parabola has its vertex as either its maximum or its minimum. This particular parabola only goes as low as -20. The lowest that this parabola goes is -20, and then it springs upwards. So I've got a happy parabola whose vertex is this far down. Remember that the vertex of a parabola is always on its axis of symmetry. So if I think about the way parabolas work, I say, well wait, if I have an x-intercept at -8 and an x-intercept at 0, my axis of symmetry is precisely between them. My axis of symmetry is going to fall along the line x equals -4. So my vertex for this parabola is going to be located at the point -4, -20. This parabola, precisely halfway between its x-intercepts, is at its minimum value, -20, from which it springs upwards, creating a big, happy parabola. The great thing we have now is a picture of this graph. Since we know how to get the equation of a parabola given its graph, all we need to do is follow those steps now. I know that any parabola with an x-intercept at -8 is going to have a factor of x plus 8. And further, I know that any parabola with an x-intercept of 0 is going to simply have a factor of x. Think about it. If I had a factor of x minus 0, that's the same as x. This is a factor that when 0 is plugged in, becomes 0. So the general equation for this parabola is that y is equal to x plus 8 times x, maybe times some a value, right? That is going to determine sort of whether the parabola is happy or sad or tall or narrow or flat. This particular parabola, I suspect, is going to have a positive a value because it's happy. Okay, I know that once I have a general equation based on my x-intercepts, I need simply plug in another point, x, comma, y, to find the equation. So let's plug it in. Y gets replaced with -20. Both of my x's get replaced with -4. Now I have an equation that if I just do a little bit of math will allow me to find the specific a value for this parabola. -20 is equal to a times, this makes +4. This is still -4. So -20 is equal to -16 times a. If I divide both sides by -16, I'm going to get that a is equal to -20 divided by -16, aka positive 5/4. I'm going to take this a value and plug it into my general equation. I now have the specific equation for a parabola with an x-intercept at -8, an x-intercept at 0, that is happy specifically such that its vertex is down 20 units. If you don't have a picture, draw a picture. Think about the symmetry of graphs, and think about how the range deals with your vertex.